Okay, today we're going to look at verifying trig identities. So I mentioned last week that we are going to be looking at something that's kind of like a proof. Well, this is what it is, sisters. So what's happening here is we are still simplifying these expressions, except it tells us the answer. Oh my gosh, yay, you know what I'm saying? So hopefully we went over these in class together, but I'll do it again for those of you who weren't listening or weren't here. So number one, I have 1 over secant squared plus 1 over cosecant squared, and it's telling me it equals 1. Our goal is to prove, to show how it equals 1. So I know 1 over secant squared is cosine squared, and 1 over cosecant squared is sine squared. Every time you do a step, you have to include your equal sign. Well, I know from my Pythagorean identity that cosine squared plus sine squared is 1. Once you have the left side equaling to the right side, you're done with your proof. Wow, good time. Okay, number 2 is a little bit tricky. So what I'm going to notice first is my denominator has 2 terms. I want to combine this into 1 term. I'm going to do that by creating a common denominator in my denominator. I know. So I'll leave secant. I'll make tangent sine over cosine because, again, if I don't know what to do, I change everything into sine over cosine. Cotangent is cosine over sine, and then include your equal sign every time. Okay, I'm going to make my common denominator cosine sine. So I'll leave secant again. This will be sine times sine, so sine squared. My denominator is cosine sine. And then cosine times cosine is cosine squared. So I created a common denominator. Well, now I notice sine plus cosine squared is 1. So let's simplify that. We love fractions in our fractions. Okay, now when I divide by a fraction, y'all know, sister, keep, change, flip. So I'll have secant x times cosine x sine x over 1, which is unnecessary. Okay, so secant times cosine times sine. Well, I know secant is 1 over cosine times cosine sine. The cosines cancel. We're left with sine equals sine. And I'm done. I see a lot of people, a couple mistakes that are seen here. You leave off your angle. So I see a lot of x's being left off, a lot of thetas. I also see a lot of, you stop right here. Once you cross the cosine, you say, hey, I got it, I'm done. No, you have to write that final step. All right, let's find a few more to do. This next one's pretty simple. I'll leave that one for you to practice. Let's look at number 4. I'll leave sine x for now. So I know cosine, and I'm going to change cotangent into cosine over sine. And don't forget your equal sign. All right, well, this is cosine squared. And if I'm going to add these fractions, I want to make a common denominator. If I make my common denominator sine, that makes sine squared in my numerator. Well, since you have a common denominator, you can make it 1 fraction, and sine squared plus cosine squared is 1. Oh my gosh, guys, don't forget your equal sign. Again, some people like to leave it right here. We are not done. Our last step has to be what you're given equals what you're given. Yay! Okay, let's find another one. Okay, number 7 is a fun one. So I have 2 cosine squared x's minus sine squared x plus 1. Okay, and I want it to equal 3 cosine squared x. Well, I know cosine squared plus sine squared is 1, but that's not what I have here. However, if I look at just this, 1 minus sine squared from your Pythagorean is positive cosine squared. And then I have 2 cosine squared here. Well, 2 cosine squared plus 1 cosine squared is 3 cosine squared. So it's really nice having these verifying because you can see what you're trying to get to. So I knew I was trying to get to cosine. So instead of changing cosine into sine, I need to get this sine into cosine. Okay, let's look at number 9. So I have 1 over tangent plus tangent. So I know my right side is one term, so I'm going to have to add these. So we are going to have to make a common denominator. I already have a denominator of tangent, so let's leave that one. And if I want this denominator to be tangent, it'll be tangent squared over tangent. Oops, forgot a C. Okay, so now adding these together, I'll have 1 tangent in the denominator. And then I can see from my Pythagorean identity, 1 plus tangent squared is secant squared. Okay, so I'm chilling here. I'm going to separate my fraction. I know secant squared is 1 over cosine squared. And then 1 over tangent is cotangent, which is cosine over sine. So don't forget here, tangent is in the denominator, so it can't be sine over cosine, it's cotangent. So cosine over sine. One of these cosines will cross out, so I'm left with 1 over cosine and sine in your denominator. And when you bring those back to the numerator, they turn into their reciprocals. So secant and cosecant, which was our goal. I hope you can hear me. I feel like I'm not talking towards the camera. So again, verifying, you have to show all your steps. It's a proof. So if I can't tell how you got from one step to the next, you're not going to get credit for it. You need to include the equal sign the whole time, and your last step has to be the same thing equals itself. Let's do like 1 or 2 more. Let me find a fun one. They're all fun though, you know what I'm saying? Let's do 11 and 13 and then we'll call it good. Okay, number 11, that numerator, I see a Pythagorean identity. 1 plus tangent squared is secant squared. I'll go ahead and change 1 over tangent squared into cotangent squared, so we can do 2 things at once there. Okay, well, I know secant squared is 1 over cosine, and cotangent squared is cosine over sine. The cosines cancel. You're left with 1 over sine, which is cosecant. These are too easy. If you're stuck and you don't know what to do, my very first step always is to change everything to sine and cosine. So if you're looking at these and you're like, whoa, sis, I have no idea. Just look for a Pythagorean identity or change everything to sines and cosines. So number 13, I need to simplify that numerator now. If I want cotangent, I know cotangent is cosine over sine. I already have a sine in the bottom, so I need to figure out this numerator situation. So let's do sine and cotangent together there. So I have sine x, cotangent is cosine over sine, plus cosine all over sister sine equals 2 cotangents. Well, this crosses out. Now cosine plus cosine is 2 cosine over sine. Oh my gosh, things are looking good because cosine over sine is cotangent. Bring down that 2. 2 cotangent equals 2 cotangent. Yay! Okay, a couple of these other ones. Don't forget your other like double angle identities, things like this. Careful there. Make sure you're looking beyond the quotient, reciprocal, and Pythagorean. So again, the goal is just to write a proof, show your steps, make the left side look like the right side.